So, this is the next lecture, in fact tutorial lecture say 10. We will discuss few problems on based on the mean value theorems. So, first problem is a function f is thrice differentiable on a closed interval, say a b, on a closed interval a b, and f of a is 0, f of b is also 0. And suppose this is, let the function f prime a is also 0. Let us suppose f prime a is also 0, f prime b is also 0. Then prove that f is thrice differentiable function on a b. We can also say such that this and this happens, this and this happens. Okay, that is better. A function f is thrice differentiable on a b such that f a is 0, f b is 0, f prime a is 0, f prime b is 0. Then prove that there exists a c in the interval a b such that the third derivative of the function at the point c is 0. Okay. So, what is given is the interval a b is given, the function f is thrice differentiable. So, it is continuous function differentiable, and at the point a the function is 0, at the point b the function is 0. So, this is the function f x. So, by Rolle's theorem, if the function on the interval a b, if the function is continuous over the closed interval a b, differentiable at the open interval a b, and at the end point the function attains the value 0, then there exists a point, say xi, in between a b such that the derivative of the function vanishes, such that f prime xi vanishes. This is the mean value theorem, Rolle's theorem. Now, again it is given that the functional value f dash a is 0, this is f dash x function, f dash a is 0, f dash xi is 0, and then f dash b is also 0. This is our f dash function. So, a function is vanishing at the point a, at the point xi, and at the point b, and it is given that f dash a is 0, f dash xi is 0, f dash b is 0. So, now apply the Rolle's theorem on the for the function f dash x on the interval a to xi and xi to b. So, by Rolle's theorem, by this theorem there exist points xi 1 in the interval a to xi and xi 2 interval xi to b such that the second derivative of the function or derivative of f prime vanishes at this point. Okay. So, now again the figure is like this, a function, this is a b, here is point xi 1, here is the point xi 2, the second derivative of the function, this is the f double dash x, vanishes at the point xi 1 xi 2, function f is thrice differentiable. So, this function f double dash is continuous and differentiable. So, again apply Rolle's theorem for the function f prime x on the interval xi 1 xi2, xi1, xi2. So, from here we get there exists a point say C in the interval a b such that, in fact, in the interval xi1, xi2 such that xi1, xi2 such that the value of the function, the derivative of the function, third derivative at this point C is 0. So, C lying between xi1, xi2, which is subset of a b. So, the result follows from there. Okay. Result follows. So, basically we are using the Rolle's theorem thrice and getting the results for this. Now, next, if p x is a polynomial, p x is a polynomial and k belongs to R, any real number, then prove that between two real roots of p x, between any two real roots of p x equal to 0, there is a root of the equation p dash x plus k times p x equal to 0. So, solution. So, p x is a polynomial of this. Prove that between any two real roots of p x equal to 0, there is a root for this. So, let alpha and beta be the roots of equation p x equal to 0. It means that is p of alpha is 0, p of beta is 0. Now, construct a function or consider a function g x as e to the power k x into p x. Now, since alpha beta are the roots of this, therefore, this implies that g of alpha is 0, g of beta is 0, because at the point alpha p alpha is 0, at the point beta the p beta is also 0. So, g alpha g beta is 0 and g is continuous and differentiable over the interval R, because polynomial is always a continuous and differentiable function over third function R, in e to the power x is also continuous and differentiable. Therefore, the function g is continuous and differentiable over the entire R. So, if we take any interval, it remains continuous and differentiable of this. Now, if we look the interval alpha to beta, over this closed interval, the function g is continuous. So, g is continuous over the closed interval alpha beta and differentiable over the open interval alpha beta, such that g of alpha is 0, g of beta is also 0. So, by Rolle's theorem again, so by Rolle's theorem, there exists a point xi in between alpha beta such that the derivative of g dash at xi is 0. But what is g dash x? Is the same as p dash e to the power k x p dash x plus k times p x at the point x equal to xi. This vanishes. So, this shows that this implies the result, because e to the power alpha xi is not 0, therefore, this has to be 0 and we get the result. Okay. So, this completes the result. There exists. Okay. Third, if f x and g x are continuous functions on the closed interval a b and differentiable on the open interval a b, then so that f of a g of b minus g of a f of b equal to b minus a into f a g prime c minus g a f prime c, where c lies between a and b. Solution. Now, function f and g are going to be continuous on the closed interval a b. It is also differentiable. Then we have to prove this thing. Now, if we look this one, then basically from the expression a, if we look this expression a, this can be expressed as, it can be rewritten as g f of a g b minus g of a f b over b minus a is this function. Is it not? This we wanted to prove, required to prove is this one. So, this suggests that if we construct the function, consider the function phi x as f of a g of x minus g of a f of x, then this function is continuous and differentiable over the interval a b, because this function g and f both are going to be continuous differentiable, and then at the point b it has this value, and at the point a it has the value 0. So, it suggests that this function phi x, if we apply the Lagrange's mean value theorem for the function phi x over the interval a b, then we may get this result. Okay. So, consider this function and apply Lagrange's mean value theorem over the interval a b. So, what we get? Phi b minus phi a over b minus a. So, there we get this thing where c is a point in between a b. So, there exists c in the interval a b such that this result hold. Now, substitute the value and get the result. So, phi of b means f of a g of b minus g of a f of b divided by b minus a, and what is the derivative of this function? F a and g prime x. So, g prime c minus g a f prime c, and that is the answer which we wanted. Okay. So, sometimes we have to see the answer, and according to the expression one can decide that can we have a suitable function, so that after applying either Lagrange's mean value theorem or Rolle's theorem we can get immediately the result. Okay. So, that is what this. Okay. Now, prove that if the equation a naught x to the power n a 1 x n minus 1 plus a n minus 1 x equal to 0 has a positive root, say x naught, then then the equation n a naught x n minus 1 plus n minus 1 a 1 x n minus 2 plus a n minus 1 equal to 0 has a positive root less than x naught. I think that is very easy question. Solution: this is the interval 0 and here is the point x naught. The function has given a positive root this. What is the function f x? F x, if I take x naught x to the power n plus a 1 x n minus 1 plus a n minus 1 x, then at the point 0 it is 0. At the point x naught is also 0 because it has a root, x naught is a root of this equation. So, function is continuous over the interval 0 to x naught, differentiable on the open interval 0 to x naught. So, by Rolle's theorem, there exists a point C in the interval 0 to x naught such that the derivative of this function vanishes, but derivative means n a naught c n minus 1 c n minus plus n minus 1 a 1 c n minus 2 plus n minus 1 is 0, where c is positive, and that is the answer which we are looking. Okay. So, this will be another exercise. If c naught plus c 1 by 2 plus c n minus 1 by n plus c n over n plus 1 is 0, where c naught, c 1, c 2, c n are real constants, then so that the equation c naught plus c 1 x plus c 2 plus c n minus 1 x n minus 1 c n x n is 0 has at least one real root between 0 and 1. Solution. So, this is given. We want this function has at least one real root in 0 1. So, if we look the function phi x, what is this function is? Construct the function phi x as c naught x plus c 1 x square by 2 plus c n x to the power n plus 1 by n plus 1. This basically I have taken from here by integrating, because when you consider this function and apply the Rolle's theorem, then finally result comes as a derivative of the function. So, if I prove that this function phi satisfies all the conditions of the Rolle's theorem over the interval 0 to 1, then there will be a point C x some point where the derivative of this function vanishes, it means this will come. Okay. So, clearly phi of 0 is 0, phi of 1 is 0 because of the condition 1, because of 1, is it not? Because of this condition this vanishes. Therefore, is phi is also continuous and differentiable over the interval 0 1, continuity as the closed interval 0 1, differentiable at the open interval 0 1. So, by Rolle's theorem, there exists a point C in the interval 0 1 where the derivative of this function vanishes, but this derivative means c naught x, c naught derivative of this. So, derivative of this c naught x plus c 1 x square by 2 C n x n plus 1 by n plus 1 at the point x equal to c vanishes, and that reads the result. So, answer. Okay. Please do that part. Answer is this. Now, using the mean value theorem, we can also obtain, or we can also derive certain inequality. Say, using mean value theorem, prove that 0 less than 1 by x ln e to the power x minus 1 divided by x is less than 1 for x greater than 0. So, let us see the solution for this. This inequality we wanted to derive with the help of mean value theorem. In fact, the Lagrange's mean value theorem will help you. So, consider the function f x equal to e to the power x, and over the interval 0 to x. Then by Lagrange's mean value theorem, we get the value of the function at a point x minus value of the function at the point 0 divided by x is equal to the derivative of the function e to the power x at the point x equal to c, where the c lies between 0 x. Okay? C lies between 0. So, by mean value theorem, there exists a c in the interval 0 x such that this result hold, and this is equal to e to the power x minus 1 by x is equal to e to the power c. Take the log. So, we get log ln e to the power c equal to ln e to the power x minus 1 by x, and this implies c is equal to ln e to the power x minus 1 by x, where the c lies between 0 and x. Now, if we take c to be greater than 0, then obviously this inequality ln minus 1 by x, this will be greater than 0, but x is also positive. So, this implies that 1 by x ln e to the power x minus 1 by x will also be positive. So, that is the first part of this result. The second side is obtained like this. Since c is less than 1, x less than x, therefore, c means what? This one, e to the power x minus 1 by x, log of this is log. So, this implies the log of ln e to the power x minus 1 by x is less than x. Therefore, 1 by x ln e to the power x minus 1 by x is strictly less than 1. So, this proves the second part of it, and this completes the results for it. Okay. So, complete. And next is, say f x is, prove that if f x is 1 over root x and g x is equal to root x, then prove that there exists a c such that c is the geometric mean of AB. So, this. So, let us see, apply the Cauchy mean value theorem. What the Cauchy mean value theorem says, the Cauchy mean value theorem is, if f and g are continuous and over the interval say a b, differentiable on the open interval a b, g prime x is not equal to 0, then there exists a point c in the interval a b such that f of x, f of b minus f of a over g of b minus g of a is the derivative f dash c over g dash c. This is the mean value theorem. So, apply this here f x and g x are such. So, find out the f prime c. So, by Cauchy mean value theorem over the interval say a b, we get from here is 1 by root b minus 1 by root a divided by root b minus root a is the derivative f prime c over g prime c, and this is equal to nothing but 1 by this is root a b, this root a b 1 over root a b, okay, equal to what is the f prime c? F prime c will be half c to the power minus 3 by 2 over this will be half by root 2 by root c. So, from here we get c is equal to under root a b, and that is the answer for it. Thank you very much. Thanks.